Hello everyone, my name is Leo. This is the supplemental video for UCSC Professor Munishkina's CSE 30 Programming Abstractions Python Notebook Assignment 2 Fraction Class. Python is an object-oriented programming language. Almost everything in Python is an object, with its properties and methods. A class is like an object constructor, or a blueprint for creating objects. For instance, in Notebook2 data structures, we can apply different methods to list, tuples, strings, such as .index method to find indexes, max and min methods to find extreme values, etc. In this notebook, you will learn how to create a class and an object in that class. Or in other words, this notebook provides you with knowledge of creating your own data types using object-oriented programming. Let's firstly talk about classes in Python. We use the keyword class to create a class, and we define the properties of objects that belong to this class using init functions. All classes have init functions, the most basic one in a class. For instance, I have a class called students, where each student is an object in this class, with three properties, age, year, and major. Now I'm declaring a variable called Leo, which is myself as an object in this class. I can print out the object's properties by simply saying print leo.age. And it will give me 19, because my input age when creating this object is 19. I can only do this when I know what properties the object has. In some cases, we do not know what properties an object has, or say the client of the class may not know. Therefore, you are encouraged to write functions which return different properties. Now, as you can see here, I am able to get properties of an object by calling methods in a class. And I'm getting the answer that I want. Here I used add property. I will talk about this later. For now, just please note that I do not use parentheses when I call them, which is different from calling a method in a class. If I do not have add property in front of the function definition, then I need to add parentheses behind it to make it work. If I do not add it, I'll just get the method itself. Only when I add parentheses, I can get the value the method returns. Now, when I try to print the object itself, as you can see here, it will print the class of this object and its address. Therefore, sometimes we need to define another method called wrapper to make the print of the object more readable and meaningful. Here, I just want to give me a sentence indicating the student's age, year, and major, so I can define my wrapper method like this. The wrapper self, I'll just return a left string. The student is self.age years old, in year self.year, majoring in self.major. And now, if I print it again, it'll give me a sentence including all the properties of this object. The student is 19 years old in year 2, majoring in computer science. Here, just please note that when I'm using the f string and referring to the object's properties, I can either use what is defined in the init function, or I can also use the method I just created to get the properties. For example, I can change self.age here to self.whatisAge. Now I'm calling the method I just defined in this class, and I can change this to self.whatisMajor. As I just mentioned, since I have add property in my age, year method, I do not need to use parentheses. Any value returned by this kind of method can be regarded as other properties of the object. It can be the same as what is defined in the init function, but also they could be something that is not defined when you create the object. It is just something the program computes for you once you have all necessary properties. We'll have an example like this later on. For my whatisMajor method, I need to use the parentheses behind it since it does not have add properties when I define it. The object's properties are changeable. You can set it to any value as you want. Let's now change my age to 20 because I'm already 20 years old. Say leo.age equals 20, and I can print leo.age. And as you can see here, the age has been updated to 20. It is preferable to modify the properties using a function just to make your code clean, or just say out of some conventions, or say to help your potential clients to use it. Say that I need to update the students' information once a year, including their ages and college years. It will be a little bit tedious if I modify them just by calling the properties one by one. Therefore, I can have a function called after a year to help me update objects' properties. Def after a year and I need to increment this age by 1, also increment the college year by 1 by default, normally speaking. And I can have another method, transfer major, to help me change a student's major. Def transfer major. But now in this case, I need another parameter called major transferred. This value would be the value I will update the properties self.major to. Self.major equals to major transferred. And now we can test it out. Say I'll call the method after a year on my method. Leo.after a year, and let's print it again. As you can see, the age and the college year has been incremented by 1. Also, I can call transfer my major on my object. Leo.transfer major, and the parameter I can say CS. And let's print out it again. And you can see the major has been changed to CS. Generally, a class has a lot of methods that you can operate on an object or among a couple of objects that belong to this class. We'll see an example about this later in the notebook. As you may have already noticed, I have a parameter called self in every function, or say methods, in this class. The self parameter is a reference to the current instance of the class, and it is used to access variables that belong to the class. It does not have to be named self. You can call it whatever you want, but it has to be the first parameter of any function in this class. If you still feel unsure about classes, objects, properties, and methods, just try to imagine that the car we drive is actually a class. Every single car is an object in this class. Every car has properties such as color, age, size, and so on. If I want to paint my car from black to green, I will most likely call a method paint in car class. This corresponds to the methods which change an object's properties. Also, when I drive the car, I call the methods speed up, slow down, turn left, turn right, and so on. And I'm operating on this object to some extent. Now let's go over the examples given in the notebook. I have a class called complex, where its objects are complex numbers. It has two properties, the real part and the imaginary part. The object-based class provides fundamental functionality for all Python classes. Explicitly inheriting from object ensures compatibility with the older Python versions and signifies that class is a new style class. However, in modern Python, you can omit object and simply write class complex and it will still work. We should be able to operate plus, minus, multiplying, and division between two complex numbers, and we implement them by defining add, sub, mul, and trueDiff methods. For the add method, we are just adding the real parts together and adding the two imaginary parts together. Then we use these two new properties to create a new object in complex class and return it. We are basically doing the same thing in the rest 3 methods, but just applying different principles. For example, the principle in TrueDive method is that complex A divided by complex B equals to complex A multiplying the inverse of complex B. We can also see if two complex numbers are the same. We implement this by defining the equal method, and the wrapper method here defines how your printout looks like. As you may have noticed, here I have two methods, starting with addProperty. The addProperty decorator is just used when you want to calculate a value derived from existing object attributes without changing the state of the object. This makes the method behave like an attribute or a property, improving code readability. For example, you can calculate the modulus of a complex number using addProperty and access it like a regular attribute. And when you call this method later, you do not add parentheses after it, just as we mentioned at the start of the video. Now let's move on to the next thing, the help function. Whenever we have a class, we can use a built-in function called help to retrieve and read descriptions written in the docstrings. Say if I run it here, I'll just get everything about this class. Now here is just some examples. C1 equals to complex 2, 3. Mathematically speaking, it equals to 2 plus 3i, and C2 equals 3 plus 4i. And if I minus C2 from C1, I'll actually get negative 1 minus 1i. If I plus the C2 back, I'll actually get C1, and it should be exactly the same thing as C1. The answer is true. And same as here, if I divided C1 by C2, then I multiply C2 back, I'll actually get C1, and also it will give me a true. Going further, I want to compare two complex numbers. We can define another method called complex LT, which stands for less than, which takes two objects because you're making comparison, self and the other. Say if self.r is smaller than other.r, then we return true directly. If self.r is equals to other.r, then we are comparing self.i and other.i to see which one is smaller. If self.i is smaller than other.i, then we'll still return true. Otherwise, we return false. If self.r is greater than other.r, we return false. This is exactly the comparison rules of tuples. That is why we are using a tuple comparison here. Now I'm comparing C1 with C2. As you can see here, as the real part of C1 is 2 and the real part of C2 is 3. So it will directly return me a false because the real part is smaller. I should run this function first. And if I change this to 3, and we'll actually make comparisons between two imaginary parts. But it will also return me a true since 3 is smaller than 4. But if I change the 3 to 5, and if I run it again, it will return me a false because mathematically speaking, C1 is now greater than C2. But if I change the real part of C1 to 2, it will return me true again because the real part is smaller than C2, and we'll put that into priority. Sometimes we want to add a new method to a class, but we cannot go back to the place where the class is defined for multiple reasons. We can add this method by saying complex.lt equals complex.lt. Complex.lt on the right of the equal sign is the function's name we defined here. And the complex with a capitalized C here is the class, and the .lt is just the method in that class. After doing this, we are able to compare complex numbers. Therefore, we can apply the sort method to the list of complex numbers. Say that we have a C list, C2 and C1, and I can just simply call the sort method, and after it's getting sorted, it will just return me a list based on the sorting result. This is the end of the video. Now your assignment is to complete the notebook exercises. Please do not hesitate to reach out to me if you have any questions or if you want me to explain the materials in the exercise section. Good luck on your assignment. I'll see you later. Bye bye.